In this video, we're going to learn how to set up a Microsoft Excel spreadsheet to calculate the benefit to cost ratio. So the benefit to cost ratio is very similar to the net present value. The net present value is going to take the present value of all cash inflows and all cash outflows. Outflows is money that you're spending, and inflows would be money that the investment is giving you back. So imagine you've bought a piece of equipment and that equipment costs some money. There you spent some money setting the equipment up, and then after that, every year, at the end of every year, you get a little bit of money back from the investment you put into it. So it's a really relatively simple thing to calculate, but depending on the information that you have and the exact nature of your cash flows, it could be different. So I've set up a spreadsheet, and my recommendation is that you hit pause and set up this spreadsheet on your own so that you can follow along. The first thing we're going to do is calculate the sum of the present value of the cash outflows. This is the money that you spend. And that, in this first example here, is just equal to the $100,000 upfront investment. Now we need to find the sum of the present value of your cash inflows. So in our first example, we have a $15,000 payment coming from your investment every year for 10 years at a discount rate or a cost of capital of 4%. So I hope that you will recognize that this is an annuity, and the sum of the present value of these cash flows is just the present value of this annuity. So we'll type an equal sign and PV, and then open parentheses. We'll click on the discount rate of 4%, type a comma, click on the number of periods, which is 10, type a comma, and click on the payment. I guess we need the negative of the payment to make sure this comes out as a positive number. So basically what we've done is we found the present value of an ordinary annuity that gives us cash flow of $15,000 every year, and our discount rate is 4%. So we'll close that parenthesis and we'll hit enter, and that gives us a number, $121,000 and some change. The benefit cost ratio is simply the benefit you got, which is the money coming into you, your cash inflow, the money coming to your pocket after you've done the work associated with this asset, divided by the investment you made in the asset. That's the cash outflow. And then we hit enter and we get a number, 1.21, right? So what this is telling us is that we have beaten our cost of capital target for this investment. So always think about this discount rate as a cost of capital target, meaning you're able to get your hands on capital that you need to finance this item, and it's going to cost you 4% to get your hands on that capital. Imagine you're borrowing the money or diverting money from an investment that could have paid 4%. And what this is telling you, since you've got a number that's larger than 1, is that you have beat your 4% target cost of capital. And what I want to point out to you is look what happens when the cost of capital changes. Let's imagine your cost of capital is 10%. So the discount rate we're using in this scenario is 10%. When we do that, we don't beat that cost of capital. My guess is that at about 8%, we're going to get really close to matching our cost of capital here. So we're dealing with something that's going to pay us about an 8% return on our investment. And if our target is 8%, this particular investment barely beats that target. It beats the target, but just barely. Now that's a real simple case where you have a constant annual cash flow, and you can use the present value of an annuity to figure that out. However, we don't always have that type of situation. Sometimes we end up with a situation where the cash flow is going to be variable every year. So in this example I have over here, we invest $10,000 or $100,000 buying some expensive asset. Next year we spend $15,000 maintaining that asset, and it doesn't make us any money. Next year we spend some money maintaining it, but net we make $2,000. And then every year after that we have some variable depending on the economic circumstances, right? Maybe this year we had a big cost we had to pay. We get some variable amount that we're going to get every single year. Now, over the 10 years, you would spend $115,000 on this asset, and it would give you $232,000. And that sounds great, but what you have to remember is you have to discount this $55,000 that's off in the future, and this $25,000, and this $15,000. So let's do the discounting action right here. Just like before, we're going to use the present value function. but we're not going to do the present value of an annuity. We're going to do the present value of some lump sum future value, and then we're going to add all those up and get the same effect as the present value of an annuity, but we can't do it with the annuity formula because our stream of payments is not constant. So our interest rate is going to be 8%. So we'll click on our interest rate, then we're going to hit F4 to lock that cell reference for the absolute cell reference. And if you've watched any of my videos, you should know how to do that. Type a comma, click on year 0 where we make the investment, and then I want a $sign in front of the D. So I'm going to hit F4 3 times to get a $sign in front of the D, so that when we drag the formula here in a second, we're always going to be pointing to column D. Type a comma, and we have to enter the payment. We're not going to enter a payment in this case. We use that when we have an annuity. So we're going to skip it by either entering a 0 or typing a second comma. And then we click on the future value, which is our $100,000. And let's be sure to stick a negative sign in front of it so the number comes out as a positive number and we have a more sensible answer. So we'll close the parentheses and we press enter. And as we expect, when you discount something in period 0, right, you're not discounting at any time period, so you should get $100,000 back out of it. We'll drag that over. Notice what I do. I just take my cursor and put it in the lower right-hand corner of the cell. I'll get a plus sign. I'll click, and then I'm going to hold my mouse and drag down. And then I've calculated the present value of all of these differing and varying cash flows. Now I'm just going to use the auto sum function to sum those. And then I'll drag that over. Now I went ahead and put that in bold because I want it to jump out at you. I wanted you to really see that number, because that's the number we're looking for here. It is the sum of the present value of the cash outflows and the sum of the present value of the cash inflows, where the inflow is the benefit you get from purchasing this asset, and the outflow is the cost of purchasing and operating this asset. So we'll type an equal sign and we'll click on the benefit. We'll type a slash to divide and click on the cost hiding out in cell G14. And then we hit enter and we get a benefit cost ratio of 1.17. What this means is that at our target discount rate of 8%, we're going to have a benefit that's greater than that target cost of capital. And again, this is highly sensitive to that discount rate, our cost of capital. So if we had 4% from our previous example, we see that this investment looks better. Now, I want to point something out. It's not better, it just looks better, right? Because for some reason we have to worry more about our discount rate whenever it's a higher number. We discount heavily when it's a higher number. The amount of money you're getting out is exactly the same, but what's changed is how much money it costs you to access that capital. That's what you want to think about with that discount rate. And as it costs you more money to access capital, the benefits have to go up in order to justify all of that. So that is how we do the benefit to cost ratio. And you might find it a useful thing some point in your life. Who knows? You might have an assignment where you have to calculate the benefit to cost ratio. Anyways, I hope that you enjoyed this quick video, and thank you for watching. Always stay tuned for more videos. They pop up all the time.